Good day. We are the group one, and we're here to discuss first come first serve algorithm.
First come, first serve. Sorry. FCFS is an operating system scheduling algorithm that automatically executes queued requests and processes in order of their arrival. It is the easiest and the simplest CPU scheduling algorithm. In this type of algorithm, processes which results the CPU first get the CPU allocation first. This managed with a FIFOQ. The full form of FCFS is first come, first serve. As the process enters the ready queue, its PCB, which is process control block, is linked with the tail of the queue, and when the CPU becomes free, it should be assigned to a process at the beginning of the queue. Characteristics of FCFS method. It supports non-preemptive and preemptive scheduling algorithm. When you say non-preemptive scheduling, is one which can be applied in the circumstances when a process terminates or a process switches from running to waiting state. In non-preemptive scheduling, once the resources CPU is allowed to a process, the process holds the CPU till it gets terminated or it reaches a waiting state. Other characteristics are jobs are always executed on the first come, first serve basis. It is easy to implement and use. This method is poor in performance and the general wait time is quite high.
Moving on with the advantages of first come first serve. The first come first serve is the simplest form of CPU scheduling form, and it is easy to program as it is the most simplest form of CPU algorithm. In terms of its algorithm, the first process is served after the next one.
Disadvantage of FCFS: it is a non-preemptive CPU scheduling algorithm, so after the process has been allocated to the CPU, it will never release the CPU until it finishes executing. The average waiting time is high. Short processes that at the back of the queue have to wait for the long process at the front to finish. Not an ideal technique for time-sharing system. Because of the simplicity, FCFS is not very efficient. Since it is non-preemptive scheduling method, that cons of this scheduling is that can lead to starvation, especially for those real-time tasks. Bugs can cause a machine to freeze up. It can make real-time and priority scheduling difficult. The waiting time is high and is not ideal for time-sharing systems because once the processor starts its execution, it must finish it before executing the other. It can't be paused in the middle. Being a non-preemptive scheduling itself, it's a big disadvantage because it can make real-time and priority scheduling difficult.
Just some addition to the advantages of first come first serve. First come first serve doesn't require any complex logic. So it just puts the process's request in a queue and executes it one by one. Eventually, every process will get a chance to run, so starvation will not occur.
In this set, we have five processes called P1, P2, P3, and P5, given the arrival time and burst time. The problem is we need to calculate the average waiting time and average turnaround time. in first come first serve order. We need to use the Gantt chart to solve the problem. As we can see, the arrival of P3 is 0, which means P3 is the first one to use the CPU and to execute. To see how long does P3 need to use the CPU, we should take a look at its burst time, which is 3 units of time. Then next, the shaded part means the CPU's idle time or the free time of the CPU. CPU has a free time because there is no process arrive at the 3 to 4 units of time. Then next, P1. Arrival time of P1 is 4 and burst is 5. Means P1 needs 5 units of time to execute. Then Gantt chart would be 4 plus 5 equals 9. So the completion time of P1 is 9 units of time. Next, P5. P5 is next based on its arrival time. The arrival time of P5 is 5, but because of P1 using the 4 to the 9 units of time, P5 did not arrive at the 5 units of time. So P5 needs to wait for the CPU until P1 complete its execution. Then P5 gets the CPU at 9 units of time. And the burst time of P5 is 4 units of time to execute in the CPU. So 9 plus 4 equals 13. 13 units of time is the completion time of P5. We have two processes left, which is P2 and P4. And both processes have 6 units of time. The CPU will automatically execute the process that has smaller number ID. Means P2 is the next to get the CPU. The arrival of P2 is 13 since 13 units of time is the completion of P5. P2 will execute at 4 units of time. 4 plus 13 equals 17. So 17 units of time is the completion time of P2. And lastly, P3. Since 17 units of time is the completion of P2, P4 will arrive at 17 units of time. And its burst time is 2 units of time. P4 needs 2 units of time to execute. So 17 plus 2 equals to 19. This is the final Gantt chart. Now we will calculate the problem. We will get the average waiting time and average turnaround time. This is the formula of average turnaround time. Completion time minus arrival time. The formula for waiting time is turnaround time minus burst time. Now this is the complete table of the turnaround time and waiting time. To get the average turnaround time, we need to plus the turnaround time and divide it into 5. So 5 plus 11 plus 3 plus 13 plus 8 equals to 40. Divide 5 equals to 8 units. For average waiting time, 0 plus 7 plus 0 plus 11 plus 4 divided by 5 equals to 4.4 units. That's all. Thank you.